The most important feature of any system is its reliability. This is the driving principle behind site reliability engineering as invented and practiced at Google. This is because you can easily lose the trust and respect of your users if your service becomes too unreliable, or is simply perceived as being too unreliable. Those countless hours you've spent designing and building the most amazing user experiences are all for nothing if your users can't access them. But it's not enough to just declare that your services must be more reliable. Reliability must be a shared goal for many different parts of your organization. Today, I'm going to start showing you how you can consistently define reliability targets for your services using SLOs. Welcome to Engineering for Reliability with Google Cloud. The first thing we need to define is what we mean when we say service. For our purposes, we'll mostly refer to one of these three. The first kind of service may be an application with a user interface that's accessed by actual humans to perform various tasks. We refer to those humans as users, and we very much care about keeping them happy so that they continue to use our service. We'll measure their happiness in terms of things like availability and performance. The second kind of service may be an API, accessed by other systems or services to send or retrieve information. We may refer to the systems that use our service as consumers. Their happiness is also important, since this interaction may involve exchanging data that will ultimately be consumed by human users. Availability and performance will again be our key measures of reliability. The final kind of service may be a data processing pipeline. Here, we'll care about things like the throughput of the system, its ability to process data correctly, and the time that it takes data elements to traverse the entire pipeline as measures of reliability. These three types of services can end up having pretty complex architectures and infrastructures, but they all share the same key feature: reliability. If that's true, then we should treat reliability like other features of our service. We'll need to plan and design for it, architect for it, and measure it. But how do we measure the reliability of our service? One way to measure reliability will be to use uptime, or the percentage of time when our service is up. However, up is hard to define and measure, and for complex distributed systems with many failure modes, this is not very useful. Instead, we can use an event or interaction-based model. We can count the number of times our users attempt to interact with our service over a given time window and divide the number of successful attempts by that total to get a percentage. But how do we define what counts as an interaction and what makes for a good or successful interaction? That's going to depend on the kind of service we're running and managing. For example, a website or mobile app can use HTTP requests separated by status code as an interaction. The thing we'll actually be counting and measuring is called the Service Level Indicator, or SLI. Next, we need a definition for good or successful. That will depend on what our users expect from our service. In this example, we're defining success for the profile page as receiving an HTTP 200 response code. Now that we've defined what success looks like, we need to define what we'll include in the total or valid set of requests. For example, we may want to exclude 400s from our account, because those are likely caused by misconfigured clients, and we don't want our reliability measure to be penalized as a result. And now our availability SLI definition is complete. Here are other potential SLI types you can consider using for your service. The SLI menu helps you choose an SLI for your service based on who your users are, what they expect from your service, and how they use it. Okay, we know what we're going to use to measure the reliability of our service. Next, we're going to set a reliability target for our service. The target we set is called the SLO, or Service Level Objective. It's a combination of our SLI, a threshold, and a window of time over which it's evaluated. The key thing we're after is a target or threshold above which users are happy and below which they're not. It might be tempting to set our target at 100%, but that would be impossible to meet and result in not being able to make any changes to our service in production. We have a simple rule of thumb for where SLO targets should be. A typical user of your service should be just about happy with the service when it operates at those targets. If the service was any less reliable, you'd no longer be meeting their expectations, and they would start to become unhappy. We call this the happiness test. When we talk about the happiness test, we say barely met, because there are downsides to exceeding your reliability target too. Once your users are happy with the reliability of your service, additional reliability has little value. Maybe your users will be happier if you built new features or made other service improvements with the resources you're dedicating to far exceeding your reliability targets. We've defined reliability as a key feature of our service and agreed to use SLIs to measure reliability and SLOs to set reliability targets. But how can we actually do those things? Let's have a look at how to use SLO monitoring in cloud operations to do just that. Start from the project dashboard in the Cloud Console. Go to the monitoring menu and select Services. This will bring you to the list of services in your workspace. As you can see in this example, there's a long list of services. Services may be created automatically from App Engine services, GKE entities, the Istio Service Mesh, or Anthos services. You can also define your own custom services. Let's start by figuring out which of our services are having issues right now. To do that, sort the list by the SLOs with firing alert column. You can see that the default service here is at the top. Let's have a closer look at it. We've defined 3 SLOs for this service. There's a calendar month response latency SLO, which is currently healthy, with plenty of error budget still remaining. There's a rolling window availability SLO, which is also healthy. Finally, we have a calendar week latency SLO. There's plenty of error budget left, but it's currently showing as unhealthy. Let's dig in to see what's going on. First, we can see how our SLI is behaving against our target. In this example, we're seeing regular periods where we're having trouble meeting that target. The error budget tab shows us our error budget burn over the selected interval. This rapid rise is a great example of why using calendar-based rather than rolling SLOs carries risk. We recover all of our error budget at once when the calendar period rolls over, rather than by actually increasing reliability. To further investigate our service, we'll give you a variety of performance and health metrics that are automatically gathered for it. Because this service was defined based on the GKE namespace, we have access to container, pod, and node metrics for that namespace. As an example, we can switch to the container restarts and uptime view to see how stable our service is. We can see that a number of our containers restarted right around the same time. Further down, we can see logs being emitted by our service and the Kubernetes entity details below that. This is how SLO monitoring in cloud operations brings together all the information you need to measure the reliability of your services using SLOs and the diagnostic and troubleshooting information that you might need to identify, triage, and mitigate issues. Thanks for joining me today. In this first episode, we covered some common types of services, the importance of treating their reliability as a key feature, and how to use an interaction-based model to measure reliability. Next, we learned about using service-level objectives to set reliability targets. Finally, we looked at how to use SLO monitoring in the Cloud Operations Suite to measure the reliability of your services using SLOs. Thanks so much for watching. Don't forget to like and subscribe to never miss out on more engineering for reliability with Google Cloud. See you soon.